Problem 19, a food truck sells salads for $6.50 each and drinks for $2 each. Question says how many salads were sold in a day, so let x be equal to the number of salads, and then we'll let y be equal to the number of drinks. Since we have two variables, we need two equations. They sold 209 salads and drinks. So salads x plus drinks y equals 209. They made $836.50. So if I take the number of salads, x, multiply it by how much they cost, so that's $6.50, and then I take the number of drinks, y, multiply it by how much it costs, 2, that's going to be equal to $836.50. Now, I have two equations, two unknowns. I have a positive 2y on the bottom. I would like the top y to be a negative 2y so that they would cancel. So I'll take negative 2 and distribute it to the top equation. So here I'm going to have negative 2 times x, or negative 2x, negative 2 times y, negative 2y, that's what I wanted, and then 209 times negative 2, so that's negative 418. The second equation is still 650x plus 2y, that equals 836.50. Now, since the y's are opposites, I will add the equations together and the y's disappear. So I have negative 2x plus 650x, so that's positive 450x. The y's, like I said, are canceled. And then when I do negative 418 plus 836.50, here I'm left with a positive 418.50. And now when I divide both sides by $4.50, here I'm going to be left with x equals letter B, or 93. So this particular food truck sold 93 salads. If they ask you for the number of drinks, that would have been y. We would have had to then plug that back into our equation to solve for y. But on the SAT, you don't want to make sure that you do too much because you're working under a time constraint. Number 19, at a lunch stand, each hamburger has 50 more calories than each order of fries. So if I let x be equal to the calories in fries, and it says each hamburger has 50 more calories, so x plus 50 equals the calories in the burgers. The question says, if two hamburgers, so 2 times x plus 50, and 3 orders of fries, so 3 times calories in fries is x, they have a total of 1,700 calories. How many calories does a hamburger have? So we need to try to figure out what x plus 50 is. So first let's figure out what x is. Here we'll distribute 2x plus 100 plus 3x equals 1,700. Or 2x and 3x is 5x plus 100 equals 1,700. Here we'll subtract 100, so 5x equals 1,600. And then we'll divide both sides by 5. So it looks like here, x is going to be equal to 320 calories. So since there's 320 calories in the fries, and it says each burger has 50 calories more, so x plus 50, that's going to be 320 plus 50, or the answer to our question, this is a grid question, 370 calories in the burgers. Problem 13, what is the sum of all the values m that satisfy this equation? 2m squared minus 16m plus 8. Now notice the question doesn't say what are the values that satisfy the equation. We don't necessarily have to find the answers. We have to find the sum of the answers, the sum of the values. And this is a quadratic equation because you have a variable that's squared. And two formulas that you really want to know: the sum of the roots of a quadratic equation are negative b over a. The product of the roots is c over a. Now, where do these letters come from, a, b, and c? A is the coefficient of the squared variable, so in this case a is 2. B is the coefficient of the variable that's not squared, so b is negative 16. And c is what we call the constant, the number without a variable, that's 8. So here we have to find the sum. We have to do negative b over a. That's going to be negative b, which is negative 16, over a, which is 2. And negative is a positive, so we have 16 over 2, or 8. So here the sum of the roots, the sum of the values, is letter D. Number 16, if t is greater than 0 and t squared minus 4 equals 0, what is the value of t? Well, let's go about solving this equation. T squared minus 4 equals 0. Again, this is a quadratic equation because our variable is squared. We're going to try to solve that by factoring or by the quadratic formula. Here, t squared minus 4 factors by the difference of perfect squares as t minus 2 times t plus 2. Now, the way you solve a quadratic equation is you take each of the factors, in this case t minus 2 and t plus 2, you set them each equal to 0 and you solve. So here, one solution is t is equal to positive 2, and one solution is t is equal to negative 2. But the question tells you that t is greater than 0, so t can't be negative 2 in this problem. So the question is asking you what is the value of t. So in this case, t is equal to positive 2, and only positive 2. Questions 22 and 23 refer to the following information, and here we have an equation, and it says at a large distance r from a radio antenna. So r stands for the distance from the radio antenna. The intensity I of the radio signal, so I is the intensity, and is related to the power, so letter P stands for the power. And we're given this equation, I equals P over 4 pi r squared. And the question says, which of the following expresses the square of the distance from the radio antenna in terms of the intensity of the radio signal and the power of the signal? Now, it's kind of very, very wordy, but basically what they want you to do is take this equation that was given to you and just simply, or maybe not so simply, isolate the r squared, because all of our answer choices are r squared equals everything else. So we want to isolate that r squared. So let's try to get it to the other side of the equation. Let's multiply both sides of the equation by r squared. So that way the r squared is eliminated from the denominator. So on the right-hand side, I have r squared times I. That equals p over 4 pi. And now to get that r squared by itself, I'm going to divide both sides by letter I. So we have r squared isolated. We have r squared equals. Now look at what we have going on the right-hand side. We have p over 4 pi divided by I. Now this is a complex fraction. Let's rewrite this right-hand side. Here I have p over 4 pi. Now the fraction just means to divide. So maybe I'll write it as divided by I. Well, the way you divide fractions is you change the division into multiplication. So divided is going to become times, and then we're going to take the reciprocal of the term after the division symbol, which is just I. So I'm going to put the I in the denominator. So I have p over 4 pi times 1 over I. So now if I simplify this, I have p times 1, which is just p, over 4 pi times I. So that's what r squared is equal to. R squared is equal to p over 4 pi I. So which of those answer choices does that match? It looks like here it matches letter B. R squared equals P over 4 pi I. So number 22, the answer is B. Number 23, for number 23, for the same signal emitted by the radio antenna, observer A measures its intensity, so letter A, the intensity, is 16 times the intensity measured by observer B. So let's do this. If observer B's intensity is I, the intensity for the observer letter A, it says 16 times the intensity of observer B. So if letter B, the intensity is I, letter A, the intensity is 16 times I. So now the question says, the distance of observer A to the radio antenna. Well, the distance is R. So if I take what we did in number 22, observer A, the distance is R. Well, I know that R squared equals P over 4 pi I, but I know that observer A, the intensity, is 16 times the intensity of observer B. So I'm going to take out the I and I'm going to put in 16I. So this distance, R, when you square it, that equals P over 4 pi times 16I. So I know that R squared equals P over, well, I know 4 times 16 is 64, so 64 pi times I. And its distance is R. So I'm going to take the square root of that. So R is equal to the square root of P over 64 pi I. Well, the square root of a fraction is just the square root of the numerator over the square root of the denominator. And I know the square root of 64 is 8. So I know R equals the square root of P over 8 times the square root of pi I. Now, what is the question asking? The question says, the distance covered by observer A, so this big mess right here, this radical P over 8 radical pi I, that distance is equals what fraction? So I'll let x be equal to the fraction. So when I solve for it, it's going to give me a fraction. The distance from observer B. Well, observer B, its intensity is just I. So for observer B, I know that the distance squared, R squared, equals P over 4 pi I. But I don't need to know what R squared is. I need to know what the distance is. So I need to know what R is. So again, I'll take the square root of both sides. So R equals the square root of P over the square root of 4 pi I. But I know the square root of 4 is just 2. So I have square root of P over 2 times the square root of pi times the square root of I. So this is the distance from observer B to the satellite. So what is the question saying one more time? The question says the distance of observer A, radical P over 8 radical pi I, that distance, is equals what fraction, x, the distance from observer B. So x times radical P over 2 radical pi I. So this is the equation, and I'll rewrite it neater for you. This is the equation that we're going to use to solve for x. So here I'm trying to solve for x, since I have x times all this stuff. I'm going to divide both sides by radical p over 2 radical pi times I. So I'll divide both sides by that expression, so that now I have x by itself, so it's going to give me a fraction. Once again, I have a complex fraction, so I'm going to take the numerator, radical p over 8 radical pi I, and as opposed to writing it as a fraction, I'm going to write it as divided by the denominator, radical p over 2 radical pi I. And then when you divide fractions, we keep the first one. So we have radical p over 8 radical pi I. Change the division to times. Multiply by the reciprocal, 2 radical pi I over radical p. And now all this mess that we've been writing over and over and over again, the radical p's cancel, the radical pi i's cancel. You just basically have 2 over 8, which reduces to 1/4. So remember the question said the distance is what fraction? There you go. There's your fraction 1/4, or answer choice A. Now, that was a difficult question. That's classified as a hard question by the SATs, but that's how you would go about solving that. Problem 15. If ax plus 2 times bx plus 7 equals this expression for all values of x, and a plus b equals 8, what are two possible values for c? So here's what we'll do. We'll take the left-hand side, ax plus 2 times bx plus 7, and let's FOIL that out. The fronts, ax times bx is abx squared. That's the firsts. The outsides, ax times 7 is 7ax. The insides, 2 times bx is 2bx. And then the lasts, 7 times 2 is 14. So that's what that left-hand side corresponds to. Now that says this is equal to this, 15x squared plus cx plus 14. Now I wrote it this way for a reason. I know that these two expressions are the same. And I can kind of see that. I see, like, for example, 14 and 14. I see that right here. If I look at the first terms, I know that a times b, has to be equal to 15, because abx squared has to be 15x squared. So a times b equals 15. Two numbers, a and b, that multiply together to give you 15. Now here's where it gets a little bit tricky. If you look at the middle expressions, what's left over, like for example here the 14 and the 14, clearly they're equal to each other. But here you have in the middle 7ax plus 2bx. This has to equal c times x. If I factor out an x from the left-hand side, I have x times 7a gives me 7ax, and then x times 2b, that equals c times x. And if I divide both sides by x, the x's cancel, so I get c equals 7a plus 2b. Let's look at these two expressions now. 7a plus 2b equals c, and a times b equals 15. Well, I need two numbers a and b that multiply to 15. So what are some possibilities? Well, a could be 5 and b could be 3, right? Because 5 times 3 is 15. I also know that a could be 3 and b could be 5, because 3 times 5 is 15. I also know that a could be 15 and b could be 1, because 15 times 1 is 15. And I know that A could be 1 and B could be 15 because 1 times 15 is 15. So these are basically your 4 nice looking choices for A and B. But now you know C equals 7A plus 2B. So if I take each of these possibilities, plug in A and B, and simplify this expression, that'll tell me what C could be. For example, in this upper left-hand corner, A is 5 and B is 3. So that would be 7 times A, 7 times 5, plus 2 times B, 2 times 3, or 35 plus 6, or 41. So C could be 41 if A is 5 and B is 3. So 41 is a possibility for C. Now, believe it or not, I actually am done, because since I know C is 41, and the question is asking me what are possibilities for C, letter D is the only one that has 41. Now, where does 31 come from? Well, if you look at this possibility right here, if you look at if A is 3 and B is 5, 7A plus 2B is 7 times 3 plus 2 times 5, or 21 plus 10, that equals 31. Now, if you're thinking you made an error, you're right. These two possibilities, A is 15, B is 1, A is 1, B is 15, these actually can't be, because look what the question said. The question said A plus B equals 8. So that's why I should have known, but now I know that these are your only two possibilities. A is 5, B is 3, A is 3, B is 5, because 5 plus 3 and 3 plus 5 is 8. So these possibilities wouldn't have worked. That's why your answer is letter D, 31 and 41. Finally, number 25, the equation above expresses the approximate height, so h is the height, in meters of a ball, t seconds after it's launched vertically. So I know that h is the height and t is the seconds. Now the question says the initial velocity is 25 meters per second. I'm assuming that's where that 25 comes from. The question says, after approximately how many seconds? So the question is saying, what is t? How many seconds will the ball hit the ground? Well, what would the height be? They need to know how many seconds, t, it would take for the ball to hit the ground. If the ball hits the ground, the height would be 0. So this is just a fancy way of saying what is t when h is 0. Because when the ball hits the ground, the ball is going up and then going down. When the height is 0 again, they want to know how long into this trip of this ball. So this question is just a very, very fancy way of saying here's an equation. Plug in h is 0 and solve for t. So that's what I'm going to do. I have h, which is 0. That equals negative 4.9 t squared plus 25t. I'm going to solve this quadratic equation because I have a variable that's squared, so it's quadratic. We can either solve it by factoring or the quadratic formula. I see each of these terms have a common factor of t. So what I'll do is I'll take out the common factor. So I have t times negative 4.9t. That gives me negative 4.9 t squared. And t times 25 is 25t. So let me now set the two factors equal to 0. So t is 0, and negative 4.9t plus 25 equals 0. Well, t is 0. When the time is 0, the height was 0. So that means the ball started on the ground. And then the other solution, if I solve this equation, I subtract 25. So I have negative 4.9t equals negative 25. And if I divide both sides by negative 4.9, I get the time that it takes the ball to hit the ground. That's going to be about 5.1. It's 5.10, and there's some more decimals, but here you go. 5.1 seconds in, the ball hits the ground. The height would be 0. So there your answer is letter D.